Yeah, good. Any seats online now? Yes. So those students, some just online. Hello. You can tell some that's about online. Not joined. They have not joined. Some of them have not joined. Yeah. So, you're satisfied with their number. You know, give this one. We wait to be for the rest of the day. All right, everyone, welcome back. Sorry for that break in transmission. It was due to technical issue from this end. All right. So we are fully back online now, and I hope we can just continue with the lecture. All right. We've done with the introductory part the other time. So we are emphasized that for computing, for data science and information systems, it is very important. It's essential to understand some of the key concepts under this thing. And we've cited some examples the other time how this information processing works. We use the issue of checking your exam results online. When you go to the ATM to make withdrawals. And the same thing also applies when some of us these days, we make a lot of shopping online and we make payment. So the moment you begin to search for the product, when you buy your product, you are making payment, information processing also takes place. Then for hospital management, patient record, social media platforms, and all the thing. So the key idea here is that raw data is processed into useful information. Raw data is processed into useful information. All right. Now, let's look at some conceptual foundations so that for us to understand information processing very well, it's very important to clarify key concepts. I don't know, many of us may be familiar with the DIKW hierarchy, which is the data, information, knowledge, and wisdom. All right. So these are the conceptual foundations that we need to clarify. Number one is the data. Data itself is an unprocessed fact. It's an unprocessed figure, and is the most basic element of information processing. And of course, it consists of raw facts, figures, symbols, observations that have not yet been processed. Sometimes many of us, we use the word data and information interchangeably. And in most cases, they do not, as far as information processing is concerned, they are not the same. They are kind of different. All right. Data on its own, it does not provide meaning or insight. They are raw, given the fact that they have not been processed. Now, for example, when we have a list of numbers, all right, we have like 65, 72, 80, all those ones. These are simply data, all right? Names, dates, and all those things that we put down, they are data. So, and the data are actually captured through input devices like keyboards, like scanners, like sensors, online forms, and all the rest. So usually computer stores this data and they manipulate the data efficiently. So, but they do not inherently understand what that data represents. So that is that data. Data on its own has no meaning until it is processed. And the other concept is information. And that information is basically the data that has been processed and organized. Data is raw, unprocessed fact and figure. But when data is processed, the outcome is information. All right. It will give you an information that has meaning and that has relevance. All right. And when data is processed, it is organized and summarized in a way that brings meaning and relevance. And processing to process data into information that gives relevance and meaning involves a lot of calculations, sorting, classification, and comparison. If we use the example the other time, the example of the raw data the other time, the numbers that we have, 65, 70, and all this one. Now, let's say we process this data and we come out with an average, which may be 72.3 now. Now this becomes an information. All right. Okay, that this is the average student performance in a particular course is like 72. The earlier one, we are just giving raw data, raw score of all students. But when they are processed through whatever system that is in place, and they now produce something like an average, 72 something, and we say this is the average performance of students, that has become an information that gives us a meaning. And based on that, we can make whatever decision we want to make from there. All right. Then the other one is knowledge. Now, when information is interpreted and applied by humans, then it becomes knowledge. So which means knowledge goes a step further by involving human understanding and judgment. All right. It emerges when information is analyzed, when information is interpreted and applied within a context, within a specific context, to guide action or decision making. Now, going back to that example, from the raw data, we have 65, 72, and all the rest. Then, when that raw data is processed through calculation, sorting, and all the rest, we came up with a figure, 72 point something, which is regarded as average performance. That is an information. Now, if we now use this information, we apply this information, let's say, okay, we can now say that, okay, based on that 72 point something, class performance is satisfactory. So that is knowledge. All right. That's an example of knowledge. Then again, another thing we need to clarify is the wisdom. The wisdom represents the highest level in the progression from data to actionable insight. Now, when knowledge is applied ethically and utilized, then wisdom comes in. I mean, that is wisdom. So, and wisdom is often shaped by experience and value. For instance, a department decided to redesign a curriculum after several years of performance analysis, may demonstrate wisdom. Let's assume the data we've been processing the other time, the average gave us something less than the initial value, and we now have a knowledge that, okay, now this class is not their performance is not satisfactory. All right. So we want to now redesign the curriculum for them. Okay. So we are applying wisdom in that place. Then let's move on to, before we go to that information processing, I think, all right, I can dictate the first attendance code for the day. I want to release the first attendance code for the day, and that is XX, X for X-ray, okay? XX HMF, XX HMF. And I need to reiterate this fact that you should try and desist from any form of malpractice with regards to this attendance code. Do not use it for any of your friends who is not in the class, and do not share that code. That is very important. I take that code again, XXHMF. All right, let's continue. Let's define information processing. Information processing, of course, refers to the systematic collection and structure handling of data in order to transform it to meaningful and actionable information. All right. It is a systematic collection, manipulation, storage, retrieval and dissemination of data to produce meaningful information. We have defined some conceptual foundations the other time, and we could see this definition, this conceptual foundation playing out in this definition. We have data, raw, that is unprocessed, all right? Then when that data are collected, they are manipulated, they are processed, they are wherever into information, and that information process. Sometimes what comes as information is the output. All right. So that's why we are saying information processing refers to what some of this process to produce meaningful information. And that information can be used for whatever, based on the context for decision making. All right. Now, and of course, data processing encompasses a sequence of logically connected activities, all right, through which raw data are collected, organized, analyzed, and stored and communicated. The process is central to both computer systems and human organizations, as it enables understanding, it enables decision making, and control and coordination. All right, and the information system involves a cycle, and we quickly look at that. So information processing as a cycle now. Information processing is not a one-time activity, okay? It is not a one-time activity. It operates as a continuous cycle. And that cycle involves, I know in some of my explanation earlier on, I've mentioned some of the elements of this cycle. We have the input, all right? We have processing, we have the output, okay? And then we have storage, and we have feedback. And this cycle underpins all computer-based and organizational information systems. All right. The cycle emphasizes that information processing is not a soft-one activity. Output, okay, 1 minute. Then output generated from all these processes at one stage often become input for subsequent processing, enabling the system to learn, to adapt, to improve over time. And virtually all computing systems, ranging from simple calculations to complex enterprise information systems, operate based on these foundational cycles. So take note of those cycles, that the system operates as a continuous cycle involving input, processing, output, storage, and feedback. And you need to remember that the cycle underpins all computer-based and organizational information systems. All right. So now, we may need to, before we go to that information, to the other types of information system, let's briefly look at some of these cycle element of the cycle one by one. Let's talk about input now. The input stage involves the collection and capture of raw data from environment and entry of raw data into a computer system. And in this case, data may originate from human users, it can be from machines, or it can be from the surrounding environment. Okay. And this may include, the data now may include numbers, it could be text, it could be images, it could be audio, or sensor readings. Now, for example, now when students enter their registration details, you as a student, when you enter your registration details into the university portal, those details constitute the input data. You have a goal, depending on whatever thing you want to do. But the starting point, when you are accessing the university portal, the starting point is to input your matric number and your password. So those things you input constitute the data. Now, the accuracy and relevance of input data are critical, because if you input poor quality data, that will lead to unreliable results. And that is a principle that is commonly described as garbage in, garbage out. So that is that's something about input. We need to rush this class because of now processing. Processing is the stage where the computer manipulates and transforms input data into meaningful results. Okay. Now, I said processing stage is where the computer manipulates and transforms input data into meaningful information. And this stage involves the applying logical rules, arithmetic calculations, and decision-making instructions, which are defined by the software program. You know, you have with the computer, you installed several software programs, and those software programs, depending on the instructions they carry, they manipulate the data, they process the data you have input, and that is the processing stage. Now, for example, in a payroll system, employee work hours are processed. You know, when the employee comes in, when they resume and the money, they have a clock card, they will input the time they come in, the time they close, or the number of hours they work on a particular product. Now, this thing at the processing stage, this information the employee has input can be processed using predefined rules to compute their salaries, their deductions, and their net pay. That is the processing stage. And like I mentioned, processing activities could involve calculations, sorting, and classifications, and all the rest. So processing is primarily carried out by central processing units, which execute instructions based on algorithms designed by whatever programmers. Then let's move to output. The output stage represents the point at which processed data is converted into meaningful information that users can easily interpret and act upon. Okay. Now, when the data has been inputted, the computer has processed the data process from the example that you have been given. Then when the output stage is when these processed data are converted into meaningful information that we now that gives relevance, that give meaning, that the users can act upon for whatever thing they want to do. All right. So at this stage, the system translates the result of computation into feasible, into readable, and audible format, making information accessible for decision making and the control purposes. Then the fourth stage in the cycle is storage, and the storage involves preserving data and processed information for future access and use. And this enables information to be retained beyond the immediate processing cycle and support. And it supports key organizational activities such as historical analysis and all the rest. Many of us, we are familiar with that term. We store our information. There are a lot of things we store on our phone. You know, when you get your results, some of you screenshot it, you store it on your phone and things like that, because you want to preserve that information beyond the immediate need, so that you can access it in future times to make whatever decisions you want to make. For businesses, whatever information that the system has processed for them, they can store it in a storage device, and they can use it at future time to make historical analysis or to forecast trend and all the rest. It could be for auditing, for reporting, and for whatever purposes they need it for. Now, storage can be classified into two broad types. Number one, we have temporary storage, which refers to the data held in the main memory, such as the random access memory, and this supports active processing, but is lost when the system is powered off. All right. Then again, and there is also permanent storage, which includes the data saved on the hard disk drives, on solid state drivers, SSDs, or cloud-based platforms. And this allows information to be preserved over extended periods. And the last stage in that cycle is the feedback. And this complete the information processing cycle by using output information to influence future inputs, future processing procedures, and managerial decisions. Now, through feedback, all right, systems are able to monitor performance. You'll be able to identify deviations, correct errors, and enhance overall effectiveness. So now, that's about the information processing cycle. We can then now move on to the next thing, the type of information processing. The types of information processing. First, we have what is called the manual information processing. Manual information processing. Now, this type of information processing is the earliest and the most basic, form of information processing. It refers to handling of data entirely by human effort. Handling of data entirely by human effort. So human perform the process entirely. There is no machine involved. All right. It is done, the processing from manual is done without the use of electronic or mechanical computing device. All stages of the information processing, like we have seen earlier, the stage of input, the processing stage, the storage, and the retrieval, they are all carried out by human agents, by human memory. All right. And the features of this manual information processing includes that it relies entirely on human effort. We said that, okay. It is slow and labor intensive. All right. Now, imagine that you want to kind of, for example, for some of us who are accounting students here now, you want to fill up the accounting ledgers used by, especially for small businesses. Can you imagine that you are recording the sales one by one? And if you have a large number, imagine that a lot of time it's going to take you, and the process is going to that will be involved. So it is slow. It will take you time to complete that record, and it will be very labor intensive. All right. So Then, okay, let's move on to the second one, which is the second type of information processing, mechanical information processing. In this one uses a bit of mechanical device. It uses mechanical devices, though it still requires human operation. It still requires human operation, but the features of this mechanical processing is that it uses mechanical devices with moving parts, but it has limited capacity, flexibility, and functionality. But it requires human control and supervision. Example include when you are using mechanical calculators to do whatever you want to do. Now, the case of recording the sales ledger for the day, the other time, the manual, you record it and do the calculation with your barrel, with whatever. But in this case, when you use calculator to make some of these calculations, then this is a bit of mechanical information processing. From there, you use your calculator to get the figures you want to get for that period. Then again, the another one is electronic information processing, and this one uses electronic computers and digital devices to process data automatically. All right, and this type of information processing, represent the most advanced and widely used form of information processing in the modern society. All right, it has high speed and accuracy, and it has the ability to handle large volumes of data. It supports automation and real-time processing. It is easily scalable and adaptable. Examples include electronic information processing, which include ATM transactions, all right, and online banking system. These are the things that are within our environment, some of the things we interact with almost daily, all right? So when you use the ATM, we have said earlier on that information processing happens in that place. And that's an example of electronic information processing. Everything you are doing, they are already automated. You will see speed, you will see accuracy, and you will see things there. Then the e-commerce platforms and all the things. And I know many of us here, we are entrepreneurs in one way or the other, and we leverage on social medias to do anything we want to do. Right? We patronize those who are online as well. So all these things we are doing, information processing takes place from there. And then it is this type of information processing, the electronic one, that makes all this processing easier, because when you input your data, in no time, in few seconds, the information you are looking for, will be released to you. So that tells you about the speed, the accuracy, and all the rest that is there. Okay. Then what else we have? Now, we are talking about information processing. What is now information processing systems? Information processing systems. Information processing system is a nice set of components, organized set of components, arrangement of resources, which are designed to collect, to process, to store, to retrieve, and distribute information in order to support individual, organizational, and societal activities. In modern computing, these systems are central to how organizations operate. It is central to how organizations make decisions and how they deliver their services. An information system does not consist of computers alone, all right? Rather, it's a socio-technical system that integrates technology with human and organizational elements. Then information system, we need to know that it accepts data as input. Then you process the data according to defined rules. Then after the data are processed, it produces useful information, which is the output. And it stores the data and information for future use, right? And it provides feedback to improve performance and decision making. So all the elements of the information processing cycle we highlighted the other time feature in this information processing system. Now, the component of an information processing system, we have hardware, which is the physical devices, all right? And it refers to the physical and tangible component of an information processing system that we use. The physical devices that we use, like the keyboard, all the things like that, the scanners, the sensors, because these allow data to be captured from users on the environment. And then the processing devices, it also includes the processing devices like the central processing unit, which execute instructions and perform calculations. There is also the storage device, such as the hard disk drives, the solid state drive SSD, which retain data and information for future use. Then we have output devices such as monitors, printers, speakers, which represent process information to you. So all these are examples of the physical hardware, components of information system. Then we have the software also, software component of information system, and this consists of programs, the instructions, and the rules that tell the hardware what to do and how to do it. Okay, it directs the hardware on how to perform specific tasks. We have on your computers, you have softwares for whatever thing you are doing. Those who analyze data, those who like the word processor and all the rest. So whatever thing you want to do, when you operate on that data, so it's that software that tells you what hardware will do. Okay. Then again, software can be classified into system software, such as operating system that manage hardware resources. Then we have application software, such as word processors and payroll systems that perform user-oriented tasks. I said again that the software can be classified into two. We have system software, such as operating systems that manage the hardware resources. Then we have application software like the word processors and payroll systems. These application software, perform user-oriented tasks. Okay. Then we have utility software, such as the antivirus programs that maintain system performance and security. Software transform hardware from inactive physical equipment into a functional and purposeful information processing system. All right. And the next one, we have data. We've talked a bit about this data, which is the raw fact and figure an information process system collects and process to produce meaningful information. Then we have people, which is also known as the humanware. This is a vital component of information processing system. They interact with the system by entering data, then operating the equipment, interpreting output, and making decisions, and maintaining the system functionality. Then also we have procedures, which have the formal rules, the guidelines, the methods that govern how an information processing system is used and managed. Then we have communication networks. These provide means for transmitting data and information between different components of our information processing system. So without this communication network, some of these things may not work properly. I'm here now giving this lecture, you are there. It is the communication networks that make this thing possible. Okay. So, and we will still, maybe we can finish by 2:30. Yeah. I need something you want to go from this. Okay. All right. Okay, I will release that now. Let me read the second one. All right, before we continue, I would like to release the second attendance code for the day. The second attendance code for the day, which is 5XJ4M. 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 Please remember, you are not to share this code. You should use it only. All right, let's move on. Categories of information processing systems. Now, information system can be classified based on the classification of information system based on the level of organizational activity they support and the type of decisions they enable. And the main categories that we'll be looking at within the scope of this class is the transaction processing systems, management information systems, decision support systems. We have executive management information systems and customer information and customer relationship management systems. Now, going to transaction processing systems now. These TPS are information processing system designed to undo the routine day-to-day transactions of an organization. These systems record, process, and store large volumes of repetitive transactions efficiently and accurately. All right. And one major feature of this TPS is that it operates at the operational level. All right. It operates at the operational level, and it forms the foundation of organizational information systems because they generate the raw data required by higher level systems such as the MIS, as we will see later, and TPS are characterized by their emphasis on speed, right? The emphasis on reliability and accuracy, because errors or delays in transaction processing can disrupt organizational operation. Now, for example, now if you use banking as our case study, ATMs are classic examples of this TPS. Now, each withdrawals that you make, each deposit that you make, and each balance inquiry that you initiate is treated as a transaction that must be processed instantly. All right? And it has to be validated against account records and securely stored. Now, in education system as well, students, when we come to the educational sector now, like in the university system that we are now, you as a student, now the student registration system that you have, it will process your course enrollment. Now, when you log into your data and you are trying to register for your courses, okay, and that system registration system will process. Now, it will process your course enrollment, your fee payment, the record updates for thousands of it, and it will record updates for thousands of students that we have within the university. Then in healthcare also, hospital admission and billing system process patient registration. Okay, the service charge, the insurance claims, and all these ones, they are treated as routine transaction. Now, a transaction processing system operates through a structured sequence of steps. First, transaction data are captured as inputs through user interfaces or automated devices. The next thing is that the system will now validate the data to ensure accuracy and completeness. Then, when the data are validated, these are then processed according to the predefined rules, okay, such as updating account balances or student records. Then finally, the transaction details are stored in databases and confirmation outputs, such as the one for your ATM withdrawal, the receipt that you get, and things like that, or notifications and then on the right. So that through automation of routine operation, TPS ensure organizational efficiency. Okay, they ensure organizational efficiency and continuity. And the system also serves as the primary source of data. Take note of that point. It serves as a primary source of data for managerial reporting and analytical systems, making them indispensable to modern information processing system. Then the next one is the management information systems. Now this one, MIS, is a computer-based systems designed to provide summarized, structured, and routine information that support managerial planning and monitoring. It provides summarized information and it supports planning, monitoring, and control. All right. It serves the middle level management and it serves the middle management. MIS typically drop data from transaction processing systems where day-to-day organizational activities are recorded. Now, these raw transactions are now processed, they are aggregated and organized into periodic reports that highlight performance, trends, and deviation from plans. Now, reports generated by MIS are usually produced on a regular basis, either daily or weekly or monthly or quarterly, and are presented in a standardized format to facilitate comparisons over time. Now, for example, we'll be using the banking system. Now, in the banking context now, MIS may generate monthly reports on loan approvals, deposit growth, or branch performance. Now, this will help the branch manager to monitor operational efficiency and identify areas requiring corrective action. Then, if you come to the education sector, education context now as well, MIS may be used to produce academic performance summaries, okay, enrollment statistics, and attendance reports that will support departmental and faculty level planning. Then if you go to the healthcare as well, hospital MIS can generate reports on patient admission, it can generate reports on bed occupancy rates, resource utilization. All these things will assist the hospital administration in managing their services. All right. And then in terms of the procedure involved in the MIS will operate by collecting transaction data from the operational systems, then processing and summarizing the data using predefined rules, okay, and it will store the results in database, then produce a structured report for managers. Then through its provision of timely and reliable information, MIS improve managerial effectiveness and organizational control. Now, the other example could include the monthly sales report, the academic performance summary that I've mentioned, inventory status report. So the information will help managerial decision-making process with a view to enhancing the effectiveness and efficiency of operations. Then we have decision support systems. And this decision support system support complex and non-routine decisions. Thank you. Now, decision support systems are interactive information systems designed to assist managers in complex and non-routine semi-structured decision-making situations. Now, unlike the management information system, which usually focus on the routine reporting, DSAs combine data, analytical models, and decision-making tools to support problem solving and evaluation of alternative courses of action. All right. part of the features of DSS is its flexibility and interactivity, okay, which allow users to explore different scenarios and assumptions. We need to note that this DSS does not replace human judgment, all right? Rather, it enhances it. It enhances human judgment by providing analytical insights that will support informed decision making. Now, these DSS now often use tools like statistical models, forecasting techniques, optimization models, and what if analysis. Now, going back to our example, using the banking as a case study as well. Now, decision support system may be used for something like credit risk assessment, loan approval decisions, and investment portfolio. Then in the education sector as well, the DSS may help university administrators forecast student enrollment trends and evaluate financial systems. Then another type of information system is we have executive information systems, which is designed for top level executives, right? And these are specialized information systems that are designed to provide high level strategic information to senior executives and top management. This system focuses on long-term trends, organizational performance indicators, and external environmental factors that influence decision making. Now, for executives like the VCA now in the education sector, some of these system is we will soon round up the class now. All right. In banking, for instance, and the executive information system may present dashboards showing profitability trends, market share, regulatory compliance indicators, and risk exposures across regions. Then in education now, that we are now, for vice chancellor and provost, now they may use executive information system to monitor institutional performance, funding patterns, research outputs, and student success indicators, and not the rest. Then the customer information management systems. These are system information processing systems designed to collect, manage, analyze customer related data to improve on service delivery, customer satisfaction, and organizational performance. Now, the slide will be available for you, of course, and probably the full note as well may be made available for you for your reading. Okay. Still have about maybe like 10. I can quickly rush it. I won't come back. Now let's look at relationship among the systems. The TPS records transactions, MIS summarizes the operations, DSS support complex decisions, the EIS guides strategy, CRM focuses on users, customers, and at all levels. Now, the role of information processing systems now, which is the key aspect of this course. Now, information processing system play a vital role in education, in business, commerce, in banking, in healthcare, in government, and in government and public administration, communication, science, and technology. Now, the role of students of MIS in education. Now we can see now, it is useful for in the student registration and records management. We have said some of this example the other time. For examination and result processing, now e-learning and virtual classroom. We are here now. I don't know wherever you are listening to this lecture. Is this role, this information processing system that allows you to listen to this lecture at this time, so we can see the benefits in education. All right. Then also in business, and commerce. It is used for accounting and financial report. There are a lot of softwares that accountants use to at least to produce monthly reports, to draw up the account, and for financial reporting. And we discovered that virtually every organization now are kind of incorporating this thing into their operational decisions. Then also it can be used for inventory and supply chain management, for sales forecasting, and all the rest. Because all these things are very key, because businesses compete on information. And whatever decisions you make as a business person, it depends on the data you have available to you. I mean, and in this case, the process data that can give you that kind of information. All right. Then also it is useful in banking and finance. We have been using banking as an example since we start this lecture. ATM and POS transactions and all the rest. It assists the banking to function. Then also in healthcare, at least many hospitals these days now, they have what is called electronic health records. You hardly see, except in some local hospitals, highly good hospitals now, you don't carry files now containing student and the patient records. Everything has been computerized, and it can be used for medical diagnostic systems, hospital management system, and all the rest. So it's also useful in government and public administration. We can use it for population census and civil registration, tax administration, e-government services. Take, for example, the national identity and voter registration now. So it is useful for government and public administration now. Then it is also useful in communication and social interactions. These days, we use information processing in communication a lot, especially in email and instant messaging, in social media platforms, in video conferencing, digital content sharing. Then we need to understand that messages that we share along these platforms, they are data. System will process this data, it will transmit it, store, and retrieve the information instantly. And the examples include WhatsApp messages, Zoom classes, social media feeds, and the rest. Then it is very useful in science and technology and information as well. Then we use it in everyday life, online shopping and digital payment, mobile banking apps, the Netflix and YouTube that you visit almost every day. These are useful there. Then, why information processing matters? It drives modern society, it improves efficiency and decision making, and all the rest. Then there are social, ethical, and security issues related to information processing. Even though it offers enormous benefit, it also raises social issues, ethical dilemmas, and security threats. Social issues in information processing include the digital divide, job displacement, and information overload. Digital divide. Now, it's not everybody that has access to computers, to phones, and to some of the things we use information processing. That create a kind of divide. That's an example of social issue. There is a job displacement due to automation. Some routine jobs now are being replaced. Those humans who do some of these routine jobs now, they are being displaced, and those jobs are being given to systems, AI, like some, for example, to take care of this routine job. Then there is also the information overload. Then okay, I've talked about that. Unequal access to computers and internet, and there is a gap between urban and rural areas, rich and the poor, educated and less educated. Then we have the ethical issues information processing include the data privacy and confidentiality. We need to understand that ethics is not about what is right or wrong. Ethics is about what is right or wrong. It is not just what is legal. Something may be legal, but it may not be right or wrong. So that's that. Then we have data privacy and confidentiality. There is data accuracy and integrity. Then the issue of intellectual property. Then the ethical use of information. We have to use information responsibly. Then it's important to avoid manipulation and misuse. And then we do not spread false or misleading data. Those are time of we have a lot of that these days. A lot of fake news moving around on social media. There are a lot of data manipulations. There are, you know, there are surveillance without consent. The key takeaway here is that just because you can access data doesn't mean that you should use it. So you should understand that using your data should be guided by strong ethics. Then social security issue, information processing includes cybercrime and hacking. We've had a lot of that. There are data breaches, there are system failures, and this is what is called CIA triad, which involve confidentiality, integrity, and availability. Now we've seen cases of bank system failures, hospital system crashes, and online exam destructions. Online exams platform have been hacked before, where informations were taken away. So all these are security issues. Now, how do we manage this issue? There is the aspect of the laws and regulations, and there is the aspect of ethical guidelines. There are the aspect of security technologies, like passwords, encryption, and all the rest. Then it's also important to have user education and awareness. So now the key thing here is technology alone is not enough, right? Human behavior also matters. When we have technology in place to control to manage some of these security issues, it's also important that our behavior, we behave in a way that protects and secure the use of data. Now, responsible users are the strongest security system. You can take that home. Now, before we bring the class to a close, I would like to release the last attendance code for the day. All right. The last attendance code for the day. And that is 4Y6LA. L for law. 4Y, Y for yam, 6LA. I take it again, 4Y6LA. Now, just to summarize everything we've been saying before we bring the class to an end, information processing is the foundation of computing, and all systems follow the same processing cycle. Electronic processing dominates modern. Please, you can please. Okay. What's the login? You have to be. Yes, sir. All right. Please make sure you submit the attendance right now. Do that now, please. Now. Submit the attendance now. Please submit the attendance now. Now you know that information processing drives modern society, and understanding it prepare you as a student for advanced computing topics. Then also note that responsible use of information is essential in the digital age. So the materials will be made available to you for reading. Yeah, thank you, and God bless you.
They congratulate you for good delivery.